All right. Go away. All right. Perfect. Now, on the warm-up, kind of like the one from Friday, if I give you or Friday? Thursday. You should be able to take an equation and get a table. So if you go to your calculator, go to graph, type in negative 2x squared plus 9. Okay, you can get a graph, which is cool, but we want to get the table, right? We know how to press Control T for the table. And remember, we like to get some negative and some positive numbers here, so we're going to go up to negative 2. Please remember, if I'm asking you for different numbers on the table, you got to go up or down to get them. And in this case, by the way, is everyone doing the warm-up? Hey. So our y values, when x is negative 2, our y's are 1, and then for negative 1, it's 7, 0 is 9, 1 is 7, 2 is 1. All right, so we have our table, and again, we graphed it, and then we press Control T to get that table, and make sure you get to the right x values. When x are these values, what are the y's? Okay. Now, we're going to go over some key features of quadratic functions. We'll do some of these together, and I'll let you try some of them, but these are notes that you're going to keep. So let me pass this out. My bad. Okay, here we go. So at the top, you can put your name. Who are you? Okay, but these are notes. So here we go. We're just identifying some key features. So everyone's looking at this with me, so that way you can do it on your own, right? Everyone's looking at the front. First of all, these graphs, do they open up or down? So number one, when I say open, okay, you think of like when a referee gives you a touchdown, right? Puts his hands up. Okay, so up. The arrowheads are pointing up. That's another way to think about it that way. So opens up. Vertex. Now, hopefully you know this from Algebra 1, but a vertex is a change of direction, a point. So wherever that graph goes down and then starts to turn up, or if it's upside down, where it's going up and it starts to turn down, either way, that change of direction is my vertex. So I want you to put a nice solid point right here at the vertex. In this case, it's right there. And what's the coordinates? So I heard negative 2. What's the y value? 1. Okay. Negative 2 comma 1. You got to be able to tell me coordinates. Okay. Plot points and also backwards. Give me coordinates of points. Please remember, x is horizontal. First you go horizontal, then you go vertical. Okay. And remember, left is negative, down is negative. Very important. Now, axis of symmetry. Do y'all know what the word symmetry? What does that word mean? If something is symmetric, what does that mean? Same in what way? Do y'all know a shape that's symmetric? A circle? Okay, why? How do you know it's symmetric? What can you do with it to show me that it's symmetric? Do what? The sides? There's something you can do to something to show me that it's symmetric. A rectangle is, but okay, you can fold it. Have you all done this before? Take a shape. If it can fold perfectly onto itself, that's symmetric, or it's symmetry. Okay, that's another way to think about it. So if something has symmetry, and this quadratic function, right? That's what we're talking about. This quadratic, by the way, this is called a parabola. If this parabola, which it does, have symmetry, that means there's a line of symmetry where it folds, okay? So think about where would that fold? It would be right down the middle. So I want you to draw that line. So draw a vertical line through the vertex. That's going to be your line of symmetry. Go ahead and draw it with a dashed line too. Okay, so we got our dashed line of symmetry. That's the line it would fold over, right? Now, that line of symmetry has an equation. So first of all, what number is it going through down here? -2. On what axis? On that horizontal x-axis, right? So the way you write that equation is it's x equals, and the x value is -2. Okay, so is everyone hearing me? Every time you do these, the line of symmetry is x equals, and whatever that number is that it goes through, okay? Vertical lines are x equals. Okay, now, next one's X-intercept and Y-intercept. Where does this parabola, this U shape, cross the x-axis? It doesn't, right? Right? This does not cross the x-axis. If it doesn't cross, then there is no x-intercept. You can go ahead and put none, or does not exist, something like that. Okay. If it crosses, if it touches it once, there might be a x-intercept. And you can tell from this, sometimes they might cross twice, and then you'd have two x-intercepts, okay? Let's talk about the y-intercept. Where does it cross the vertical y-axis? So put a point there. So yes, the y value is 5, but I want to write it as an ordered pair. So I want to put it as like an x comma y point. So what is the x value of this point? Well, that's 0, and then the y value is 5. So remember, when x is 0, the y value is the y-intercept. Do you see that's different than just putting 5? Okay, you want to put 0, comma 5 for the y-intercept. All right? What? Uh-huh. So for x-intercept, it's like a number, comma 0. And if there's more than one, you put them both. We're going to do that on number 2 now. So you get the idea. You could probably already do most of number 2, right? So let's do it. Number 2, which way does it open? Down. Okay, go ahead and put a point at the vertex, right? Let's put a point at that vertex. Do you see it's at the top now? It's where it changes direction. Okay, what are the coordinates of that vertex? Okay, -2, comma 4 is correct because it goes left 2, up 4. Okay, axis of symmetry. Draw it first. Okay, and this goes through what axis at what point? What? It's another -2, so what do I write over here? X equals -2 gives you that vertical line. Okay. All right, now this time we got some x-intercepts. Where does it cross the x-axis? Go ahead and put some points there, like make them a little bit more bold. Okay, so -4, comma 0 is a x-intercept. And in this case, it's not the only one. So we have an x-intercept here, and we keep going, and we got one right here. What is this x-intercept in the center there? Zero, 0, right? 0, comma 0. There's a special name for that point. Don't know what it's called? the origin. So 0, 0 at the very center is called the origin. Dang it, these zeros look terrible. Whatever. All right, so I have 2 x-intercepts. Does everyone see that it's possible to have 2 x-intercepts? Cool. And then what's my y-intercept? Yeah, see how up and down, the graph crosses right here. Even though that was the x-intercept, at this exact point, it can also possibly be also the y-intercept. And it is. So it crosses the y-axis at 0, so we write 0, 0. Sometimes your x-intercept and your y-intercept can be the same at 0, 0. Sometimes. Okay. All right, now down a little bit more. Let's do number 3 real quick. Up or down? Up. Vertex. Put a point there. What is that vertex? So that's right at the origin. So it is 0, 0. What about the axis of symmetry? Okay, tell me exactly what I should write though. For a x equals 0, right? Axis of symmetry is always x equals. So x equals 0. What about an x-intercept? It touches right here at the vertex on the x-axis. So it, once again, 0, 0. And what about the y-intercept? Where does it cross the vertical line? Well, once again, right at the origin, 0, 0. Do you see when the vertex is at 0, 0, your x and y-intercept and your axis of symmetry, a bunch of 0, okay? So if it's centered at the origin, kind of simple. I mean, so that's a 0, by the way. Okay, so I want you to try 4, 5, and 6, and then we'll go over it in a little bit. Please notice number 6 is like not the best example, so you're gonna have to like estimate a little bit, okay? But try 4, 5, and 6. 6 is more of like a bonus, but we're gonna go over those in a few minutes, okay?